Okay, today we have Professor Adrian David Cheok visiting our department. He is a director of the Imagineering Institute in Malaysia. He's also chair professor of purposive computing at the City University of London, as well as a chair professor at the Faculty of Computing at University of Technology Malaysia. You have been doing a research on senses, starting with audiovisual content, meaning augmented reality applications. Actually, already a couple of decades ago, you did your first human Pac-Man application in Singapore. But after that, you've been looking more about other senses besides seeing and hearing. Starting with touch, which you've been looking quite a lot. Could you tell us what do you think are the main findings in digitalizing and communicating touch?
Well, at first I wanted to just make some devices where we could communicate by touch, but then we of course wanted to see whether they're effective and whether they have any advantage. Right? So we actually worked with collaborators, for example, in the neuroscience or medical school, psychology. And so I'll give you one example where we did a project with a psychology professor, and she made 3 measurements. One was with the physical touch. So you have the physical friend touching you while you're watching some scary movie or scary pictures or something. And then another one is with the hugging pajama, and which your friend operates. And the third case is the hugging pajama randomly triggered with a computer. So the good news is that the effect of being physically touched by your physical friend and also through the hugging pajama had almost a very similar effect. So because it's a well-known fact that if you watch something scary and you're being touched by a friend, it reduces your stress. So it had similar effect with the hugging pajama. And then various other studies have shown that virtual touch with these devices actually can have very similar effect to physical touch. Right? Yeah. But one thing we found is that when we randomly touch people with a computer, they also reduce their stress, even though we told them it's just a computer hugging you. But I think that is because we experience touch on many levels. So one is the physiological level. Even if you're randomly hugged by a computer, it may be pleasurable because of the physiological effect, right? But then, of course, there's many different levels. So at the top level, we have the mental model of who is touching us. Is it our best friend? Is it our children? Is it our spouse? And this adds to the communication, right? So touch is, I think, is it's very difficult to describe in mathematical terms because there are many different levels of experiencing touch, which I think may be very different. For example, when we with vision, maybe it's much more analytical. Touch is maybe different from that, more emotional, together with actual physiological aspects.
You have had the chance to create a bunch of really interesting devices when researching this touch. What is your favorite device of all of them?
Well, it's hard to say because it changes all the time. But I would say that from the point of view of interest, our Kiss Messenger has definitely received more interest than most of our works. And even today, we still constantly get emails from people who want to buy the device, but it's not on sale yet. We're trying to work with some companies maybe to make it into a product. But it's received a lot of interest, and when my PhD student who developed the latest version of the Kissinger is now like a kind of YouTube celebrity. So millions of views of her research videos, which you don't often get in academia. But I think the important thing is when we make the devices, I think the most important thing has been that when we get a lot of feedback from different parts of society, and that helps us to think of what should be the next stage of our research. For example, for the hugging pajama, we received some email from someone, a young girl, I think, from America, teenager, and she said she wants to buy the hugging pajama, and I said, sorry, it's not on sale. And I said, why do you want to use it? And she said her father is in prison, right? And that's the kind of thing we never would have thought of, right, when we're doing our research. So I think when you make the devices, people will find many different ways to use it, and some of them can be very positive ways.
Then going further, lately you've been looking at smell. The earlier work was about it's a digitally triggered smell sensation, but which is basically chemical. And now the later work has been more about digitally creating the smell sensation. Could you tell a little bit about the difference with that and their usability?
Yeah. Well, the work we did called Senti, a device that you can plug into your mobile phone and emits a smell, and we've done various collaborations with that. As I mentioned, with Mugaritz restaurant in Spain, with Oscar Mayer in USA, and that basically is a device that has chemicals. It's controlled from the app, and it can release the chemicals at the right time, during the app. So it can be used for communication. For example, you can send someone a smell of a rose for their birthday, but that is a kind of short-term solution. These kind of devices, because no one wants to keep putting a new plug into their phone or refill the chemicals. So ultimately, we have to find a way to send the signal using just electricity, and then we can send the signal through the internet. And that's why we now are working on stimulating taste and smell directly by electrically stimulating the taste and olfactory receptors. But it's still a long way to go before this would be commercial product, I think. I mean, even if you look at virtual reality in the 1980s, people were saying it's coming out now, right? So there were so many movies and books about virtual reality in the 80s. But now, 30 years later, it's still not really consumer product, although it's getting there after 30 years. So it's going to take a while. And my question, to myself and also to our lab is maybe by the time we can make controllable versions of these commercially, someone has invented a brain interface. Then you don't need to stimulate the senses anymore. You just stimulate your brain directly. Yeah. That may happen. Yeah.
But talking about the taste, you already mentioned that you managed to digitally create at least a sour and sweet taste. Can you tell us how you actually do that?
Well, I'm an electrical engineer, so I'm not an expert in the physiology. But I think, and reading the literature, we think that it's essentially giving the receptors, which are just underneath the surface of the tongue, electrical stimulation, and then this will cause taste perception in the brain. But we haven't concretely proved that, because we would have to put people in, for example, maybe in fMRI machine, and then see what is the actual signals. The problem is that even the fastest MRI now, maybe it takes 1 minute per scan, right? Even the fastest one, which is too slow to measure this kind of, I think it takes 200 or 300 milliseconds to taste something on your tongue. So unfortunately, we still don't have a real good way to concretely say what is happening. But we think it's because stimulation of the taste receptor on the tongue. But there may be there is some electrical sensors in our tongue. All right, there's another theory that we have actual sensing of electricity, right? But we need to have better equipment before we can concretely explain why that happens. But at least we do know it does happen, all right? So if you come to our lab, and also we take the demos around the world, people experience the sour taste, sweet taste. Definitely they experience it, but why? We can't concretely say at this point. Yeah.
Well, interesting to see where that goes.
Yeah.
Talking about the future, I know that you're interested in artificial intelligence research. So can you share us your vision of artificial intelligence in future? What do you think will be the breakthrough applications when using AI?
Yeah, so more and more of our work now is going towards artificial intelligence, and a few different angles. So one is that this work with multi-sensory communication can be used for like a telephone, where you call your wife or call your children and have a simultaneous conversation. But of course, it could also be used for communicating with a virtual person, like in a computer game or video, 3D world, right? So we started to think more and more about this, and then we need, if it's a virtual character, then they should be able to have conversation with you, but also should be able to understand, for example, touch, taste and smell, and this will need a new kind of artificial intelligence. A lot of AI now, of course, is very much focused about the logic, solving problems of a more mathematical nature. But if we can also get AI to understand touch, taste and smell, then I think in the future we will be able to communicate not just with humans but also with virtual humans. But for the applications of AI, I think it is going to be a transformational technology, like the steam engine. Yeah, sure, it powered trains and big machines in factories, but the real thing was it transformed the whole world. It brought in the industrial age, and also electricity, similar. So I think AI is also going to be a similar transformational technology. Everything will have AI. Your car will drive with AI. You go to the hospital, you'll be analysed, diagnosed with the AI. The children will be taught by AI robots, maybe. So I think it's going to be a transformational change, and the question actually will be, what can't AI do? And there was a very interesting article in The Economist magazine. Some of you might read that, but they had a very interesting graph, and they asked a lot of famous AI scientists from around the world. I think someone read that article, and they showed what were the scientists' prediction, when can certain jobs be done by AI. So of course simple ones like truck driver probably can be done next 5 years. All right, so it is pretty dumb for a human to sit there for 10 hours driving a truck, right? You can just get a robot to do it, right? So but then if you look at that graph, within about 85 years they predict that every job can be done by AI, including, by the way, professors. And interestingly enough, AI scientists can be replaced by AI sometime in the future. So I think the question actually is going to be, what can't be done by AI? I'm pretty sure everything can be done by AI. And then the question is, what will we do? So, what will humans do after that time? Yeah. I don't know the answer to that.